guys, in this video we're going to go over fluorescence and how a fluorescence tube works. So fluorescence, first just thing we're going to recap here is that we know that in atoms they have different energy levels, okay? So maybe you want to think about how you've got a nucleus. That's a terrible colour pen, but maybe you want to think about how you've got a nucleus from your GCSEs. You've got a nucleus, and then you think about you've got your electrons orbiting in these shells. So 2 electrons in the first shell, maybe you had 8 electrons in your second shell. Okay, you want to kind of imagine like this. You can imagine these shells are kind of like your energy levels. Okay, so let's say we've got your nucleus. So we've got our nucleus, and then we've got our n equals 1. Okay, that's our ground state that the electrons want to be in. Then you've got your n equals 2 level, your first excited state. Then you've got your n equals 3 level, your n equals 4 level, your n equals 5 level, and so on and so on and so on. And then we can say that it's been ionized. Okay, so electrons, they want to exist in their ground states. That's where my electron is. And if we give them enough energy, what I said there is we give enough energy, we can completely free it from the atom. We can completely free it from the atom, and we can say it's been ionized. But what normally happens is that normally we have some ray of light that's maybe shone on my atom. So say we say shun ray of light, they get shone on my atom. That ray of light, if it's got the correct energy, can get absorbed by that electron, and that electron then will get promoted to a higher energy level, okay? So let's say again, we have got that energy of light. So we know energy of light is E equals hc over the wavelength. So if I know what the wavelength of light is, I can figure out what the energy of that light is. And if the energy of that light is exactly equal to an energy level gap, so this energy between 1 and 3, we can see that electron gets promoted to a higher energy level. It gets excited. But that electron is unstable there. So because it's unstable, what happens then, it's going to fall back down to a lower energy level. So instead of going the whole way back down to 1, it might just go back to 2. So when it falls back down to a lower energy level, it's going to emit some energy of light, again, exactly equal to that energy level gap. Okay, so we can figure out what the energy level, the difference in energy between those two states are, and that's going to be the energy of light that gets emitted out. And then when it's here, it might fall back down to its ground state again, emit another wavelength of light of another energy of light. So that's what fluorescence is. Fluorescence is when we excite an electron, and instead of falling straight back down, it can just fall back down in stages, and that's why we just keep getting that wavelength of light emitted off. So how does the tube work? So in the tube, what happens here is we've got a filament. The filament gets heated, and when it gets heated, we're going to get those electrons emitted. Okay, so we're going to get those electrons emitted from that filament. Okay, so we've got electrons inside this tube. This tube is going to be at really low pressure, and it's going to have mercury atoms inside it. So this is my atom, mercury is inside it, and I know inside that atom, again, we've got these different energy levels. So what's going to happen is those electrons are moving quite fast. Some of them are going to end up colliding with that mercury atom. And when they collide with that mercury atom, what happens then, that electron in its ground state can absorb the energy from that collision with that electron and gets promoted to a higher energy level. So it's promoted to a higher energy level. And that electron that first collided, so there's my electron coming in, colliding, it's going to move off, but it's just moving off with less energy than before. So initially this electron here was moving super fast, then it collides with this mercury atom, and now it comes off moving much slower because it gave its energy to the electrons inside the mercury atom. So electrons inside the mercury atom get promoted to a higher energy level. And then what happens is, remember they're unstable there, so they're going to de-excite, fall down to a lower energy level. So they're going to fall down to a lower energy level. And when they fall back down to a lower energy level, they're going to emit a wavelength of light, an energy light, exactly equal to that energy level difference. And that's going to be light in the UV region, the ultraviolet region, which we cannot see with our eyes. So what then happens to this UV light? That UV light might go and hit that phosphorus coating, the coating that's around the tube. So the coating around the tube is made of atoms that have different energy levels. And when that light, that UV light, hits the phosphorus, what might happen then is that one of the electrons in that ground state might get promoted to a higher energy level. And then it's going to de-excite, and it's going to fall back to its lower energy level. And when it falls back down, it's going to emit different energies of light exactly equal to those energy level gaps. And these energies of light that get emitted are in the visible region of the spectrum, and that's why we can see it then with our eyes. So again, the key thing is here, it's different atoms inside the phosphorus and on the coating, because different atoms have different sizes of these energy level gaps. So that's why mercury, because of its size of energy level gaps, it emits a UV photon, and that UV photon gets absorbed by the phosphorus, and then it de-excites, emitting light in the visible region of the spectrum.